Welcome back to Silicophilic. I thought my SSD was fine, Windows was clean, Temps looked normal. But then boots slowed, games stuttered, file transfers dragged. The drive wasn't dying, I was suffocating it. And the scary part? Most Windows users are doing the same thing without realizing it. Here is what I did to fix it and why you should too. Why your fast PC suddenly feels slow. Here is the mistake people make. They treat SSDs like old hard drives. Fill them up, delete a few files. But SSDs don't work like HDDs. And once your SSD gets too full, performance doesn't just decline. It collapses under pressure, and SSD constantly reorganizes data in the background. That process is called garbage collection. When free space disappears, your SSD has to move existing data around just to write new files. Imagine trying to park cars in a parking lot that's already full. Every new car means moving 3 others first. That's what your SSD is doing internally constantly. And this creates something called write amplification or WAF. It is an undesirable phenomenon where the actually physical data written to the NAND flash memory is a multiple of the local data intended to be written by the host system. The drive starts doing significantly more work than necessary, which means there are slower writes, inconsistent responsiveness, random stutters, thermal spikes, and reduced lifespan. Here is what I did first. Open Windows settings, then head to Systems, then Storage. Look at your SSD usage. If your drive is above 80% full, especially on DRAM-LESS SSDs, you are already entering the danger zone. And yes, that massive 120 GB Call of Duty install, it matters. The ideal SSD usage is to keep capacity under 70%. It is still acceptable if the drive stays under 80%. Once the SSD reaches 90% or more, it enters the dangerous zone where performance and lifespan can be seriously affected. Your SSD needs breathing room. Free space isn't wasted space, it's performance headroom. The Windows feature people keep disabling. We often disable Windows optimization because they think it's defragging SSDs. That advice is destroying performance. When you delete a file, the SSD doesn't instantly erase the physical data. Windows has to tell the drive the space is safe to clean. That communication happens through a command called trim. Without trim, your SSD cleans blocks without trying to write new data at the same time, which doubles the workload. That's why systems begin feeling sluggish even when benchmarks look okay. How to check trim? Here is how I check trim. Open Windows Terminal as administrator, run this command in the terminal window. If you see disable delete notify equals 0, then this means that trim is enabled. That's good. If it says 1, your SSD optimization is disabled and your drive is working way harder than it should, then I manually retrimmed the drive. Here is what to do. Run this command in the terminal window. This tells Windows to clean invalid data blocks properly. Not defrag, not reorganize, just clean. This makes a huge difference. The heat problem nobody talks about. Then I checked temperatures, and this is where things got ugly. Because modern NVMe drives are insanely fast, but they run hot. Most people monitor CPU temperatures, some monitor GPU temperatures, almost nobody checks SSD temperatures. Meanwhile, their NVMe drive is sitting directly underneath the GPU, dumping heat onto it for hours. Once these drives hit around 70 degrees Celsius, they begin thermal throttling, which means the SSD intentionally slows itself down to survive, and suddenly your 7000 MB's drive feels like a SATA SSD from 2016. So I installed the manufacturer software, and if your SSD brand has software, use it. You can go for Samsung Magician, WD Dashboard, or Crucial Storage Executive, whatever matches your drive, because this gives you temperatures, firmware health, read-write stats, trim controls, smart diagnostics, lifespan estimates. If your SSD doesn't come with its own software, that usually means one of the two things. It's a budget drive or it's a very budget drive. In that case, you should use Crystal Disk Info. It's still one of the best tools available for checking the health of an SSD. The DRAM-LESS SSD trap. Now this is where a lot of people get caught. Cheap SSDs advertise massive speeds, but many of them are DRAM-less. That changes everything. A proper SSD uses DRAM cache to track where data leaves. Without DRAM, the SSD has to search its own flash memory repeatedly, which is dramatically slower, especially once the drive gets fuller. That's why cheap SSDs often feel fast for the first few months, then suddenly become inconsistent. Not because they are broken, because they are overwhelmed. The survival rule for DRAM-less SSDs is simple but strict. You should always keep the drive's usage below 70% to avoid slowdowns. Large file transfers should be avoided because sustained writes can quickly overwhelm the controller. Temperatures need to be monitored closely since heat can damage these drives faster than you expect. And above all, trim should never be disabled because it's the key to keeping the SSD efficient and preventing long-term performance loss. Is your SSD actually dying? At this point, I needed to answer the real question. Is the SSD slow or is it dying? This is where Smart Data matters. Smart Data is the built-in health monitoring system inside SSDs and HDDs. It tracks reliability indicators like error rates, bad sectors, temperature, and wear levels, helping you tell whether your drive is simply slowing down or actually fail. If your SSD's health status changes from good to caution or bad, don't ignore it. That's your early warning sign. Every SSD has a limited lifespan measured in TBW, which stands for terabytes written. This number represents the total amount of the data that the drive can handle over its lifetime. If you have spent years editing videos, rendering projects, moving massive game libraries, or recording gameplay, you may be getting close to that endurance limit, especially if the SSD is a cheaper model. The 3 things I changed. So here is what fixed my system. Not registry tweaks, not gaming optimizers, not fake performance scripts. Just 3 things. First, I reduced SSD usage below 70%. This made an instant improvement. Then I re-enabled Windows optimization and trim, and the stutters disappeared. Next, I added proper airflow and monitored SSD temperatures, and suddenly the drive behaved normally again. So most SSDs don't suddenly become slow, they get buried under heat, data, bad optimization advice. And the worst part, Windows actually keeps working just enough that users never realize what's happening until the entire system starts feeling heavy. So before you replace your SSD, check capacity, trim, temperatures, health status because your dying SSD might just be suffocating. If this video helped, hit like, subscribe and share your own thoughts in the comments. Thanks for watching and we will see you in the next video.